So, dear students, in the previous session, okay, we have seen multi-level paging and with all the questions and all that. So, I think all of you solved the workbook questions of multi-level paging, okay, related questions in the workbook. So, next in the continuation, we will move on to the next topic, that is inverted paging. So, what is the meaning of inverted paging and why we are going to implement all that, we will understand in detail. So, before that just okay, copy the diagram को copy करो अच्छे से, copy the diagram. So, same thing, notes को turn करो, notes को turn करके fresh page में copy करो. Is that clear? So, please turn your notes and copy that in a fresh page. Okay, so copy that. So, please copy this carefully. So, please copy this. Notes को turn करके fresh page में copy करो. So, we will discuss why we are going for okay inverted paging and how we are going to implement the inverted paging. Everything we will understand in detail. So, please copy the diagram. I will wait 5 seconds in the live. So, आप लोग pass करो. Pass करके मैं side हो जा रहा हूँ. So, this is a process number, okay, process ID, okay, process 3, okay, process 6 and all that. This is a page number and this is a frame number. Okay, I will explain all that in detail. So, please copy that. I will wait 5 seconds in the live. आप pass करो आप लोग. Okay, right. So, let's discuss, okay, what is the meaning of inverted paging and why we are going for inverted paging. Understand here. So, in the inverted paging, understand here why we are going for inverted paging. Let's understand that first. Now, in the conventional paging, just listen carefully. In the conventional paging, so abhi tak apan jo padhe, okay, that is like single level paging or multi level paging, normal conventional paging. Remember, every process will have a okay, its own page table. Okay, paging will be with respect to every process, and I told you every process will have its own page table. हर process का अपना अपना page table होगा. In the normal conventional paging, every process will have its own page table. Okay, you know that already clearly. Now remember, if the number of processes in the system are getting increased, then the memory required to maintain the page tables of the processes will also increase. Okay, I am repeating. If the number of processes in the system are getting increased, okay, then the memory required to maintain the page tables of the process will also increase, because every process will have its own page table. Every process will have its own page table. अगर बहुत सारे process memory में आ रहा है, okay, create हो रहा है, तो बहुत सारा page table बनेगा. So memory required to maintain the page tables of the process will also increase. So that is the reason. To avoid the overhead of maintaining page table for every process. To avoid the overhead of maintaining page table for every process, the concept of inverted paging is implemented. In the inverted paging, only one page table will be maintained for all the processes. In the inverted paging, only one page table will be maintained for all the process. So you should have a complete clarity. आपको अच्छे से clarity मालूम होना चाहिए. Why we went for okay multi-level paging and why we are going for inverted paging. Okay, वहां पे मैं क्या बोला था और मैं यहाँ पे क्या बोल रहा हूँ, आपको अच्छे से समझ में आना चाहिए. राइट, मैं यहाँ पे क्या बोल रहा हूँ बताओ, यहाँ पे क्या बोल रहा हूँ. Why we are going for inverted paging, क्यों जा रहा है inverted paging में? To avoid the overhead of maintaining page table for every process. To avoid overhead of maintaining page table for every process, the concept of inverted paging is implemented. Okay, right. To avoid overhead of maintaining page table for every process, the concept of inverted paging is implemented. Okay, understand here. Okay, मैं multi-level paging में क्या बोला था? Multi-level paging में क्या बोला था मैं? बताओ. Multi-level paging में क्या बोला था? To avoid overhead of maintaining large size page table बोला था. To avoid overhead of maintaining large size page table, and that is the reason we went for what? Multi-level paging. That is the reason we went for multi-level paging. Okay. So अभी यहाँ पे क्या बोल रहे हैं बताओ, यहाँ पे क्या बोल रहे हैं? To avoid overhead of maintaining page table for every process, the concept of inverted paging is implemented. So in the inverted paging, only one page table will be maintained. Only one page table will be maintained for all the processes. Only one page table will be maintained for all the process. Is that clear for everyone? Right. So how we are going to implement that? That we are going to study now. Okay. So this is a simple and very easy. Okay. So note down the points first. So before we move on, just note down the points. Note down. To avoid the overhead of maintaining page table for every process. To avoid overhead of maintaining page table for every process, the concept of inverted paging is implemented. To avoid overhead of maintaining page table for every process, the concept of inverted paging is implemented. Full stop. Note down. Next point. In the inverted paging, only one page table will be maintained. In the inverted paging, only one page table will be maintained. Only one page table will be maintained for all the processes. Only one page table will be maintained for all the processes. Okay, understand here. So in the inverted paging, only one page table will be maintained for all the processes. Is that clear for everyone? Right. Okay. Now, so that is about okay inverted page table. Right. So understand here. Okay, inverted paging. Okay, only 2 points. Now come back to this here. Understand here, in the inverted paging, we are maintaining only one page table for all the process. Okay, we are maintaining only one page table for all the process. Okay, look at here. We are maintaining only one page table for all the process. So this is the inverted page table. Okay, just note down. So this is the page number. Okay, page number, and this is the corresponding process ID, and this is the corresponding frame number. Okay, corresponding frame number. Okay, so understand carefully. Let's try to understand. Okay, this is the frame number, corresponding page number. This is the corresponding process ID. Okay, right. So understand carefully. Right. So understand here, okay, in the inverted page table, if you observe this, okay, if this is an inverted page table here, so this is a page number, corresponding process ID, corresponding frame number. So look at here, page number 7 of process 3 is available in the frame number 0. Understand here, page number 7 of process 3 is available in the frame number 0. So that is the meaning of this. Okay, so page number 3, okay, page number 7 of process 3 available in the frame number 0. So page number 3 of process 6 is available in the frame number 1. Remember, we are maintaining only one page table for all the processes. Okay, now don't confuse here. You are having page number 5 here. Okay, look at your page number 5 and page number 5 here. So no confusion, because the page number 5 of process 4 and is the page number 5 of process 7. Is that clear? So no need to worry about okay, those things. Now understand carefully. And next, okay, so this is a page number and process ID and corresponding frame number. So if you observe this inverted page table here, you will understand one important point. I made the diagram so that you can guess, okay, what is the important point. If you observe the inverted page table, or it is also called as sometimes a frame table. In the inverted page table, how many entries are there? 7. कोई बोल रहा है 7 बोला क्या? ओके, मारूंगा पकड़ के. ऊपर भी देखो कुछ है यार. 0 से स्टार्ट हो रहा है. 0 to 7 टोटल 8. So 8 entries are there. थोड़ा ध्यान रखो अच्छे से, right? So total 8 entries are there here, right? Now remember, total you are having 8 entries. Why you are having 8 entries in the inverted page table? Because that is same as number of frames in the PAS. Okay, number of frames in the PAS. How many frames are there in the PAS here? Okay, 0 to 7. Okay, look at here, 0 to 7, total how many frames are there? 8 frames are there. So, okay, now it means number of entries in the inverted page table. Number of entries in the inverted page table is same as number of frames in the PAS. Number of frames in the PAS. Is that clear for everyone? Right? Number of entries in the inverted page table is same as number of frames in the PAS. Is that clear? So, inverted page table में कितना entries है यहाँ पे? 8 entries है. Why? Because that is same as number of frames in the PAS. Is that clear? No doubt. Note down this point. Important point. No doubt. Number of entries in the inverted page table. Number of entries in the inverted page table is same as number of frames in the PAS. Number of entries in the inverted page table is same as number of frames in the PAS. Number of frames in the PAS. Okay. So keep that in a box. डब्बा में लगा उसको. Important point है. डब्बा मतलब important. डब्बा बोलते हैं, डिब्बी बोलते हैं, whatever it is. Okay, right? So डब्बा means small box. Dabba means big box. Dibbi means small box, right? Okay, right. So fine, it's okay. So understand here. So okay, number of entries same as number of frames in the PS. Next, now I am coming from the first. Listen carefully. Now, okay, the CPU always generates a logical address. Just listen here. It's very, very simple and easy. So CPU always generates logical address. Now, what is this here? P means what? Processor. Okay, processor always generates a logical address, and logical address will be divided into what? Two parts. That is P and D. Logical address will be divided into two parts, P and D. So P will tell you what? Page number, and D will tell you what? Page offset. Okay, that is same here. So this is a page number, okay, and the page offset. So whatever we studied, that is the same only. Now, so you take the page number. When the CPU want to generate the physical address, translate from logical to physical address. So it will search in the page table here. It will search in the inverted page table with the two parameters. So that is the page number and corresponding process ID. Okay, it will search with respect to two parameters. Okay, page number and corresponding process ID. Okay, just listen here. So the CPU will take the page number. Okay, from here page number will be available in the logical address, and the process ID कहाँ से आएगा? Process ID. Okay, it will directly get from the PCB, process control block. Is that clear? See, all the details of the process will be available in the PCB. Remember, the CPU will execute only one process at any point of time. The CPU will execute only one process at any point of time. CPU will execute only one process at any point of time. So whichever the process it is executing, it will take the corresponding process ID. okay, corresponding process ID from the PCB. Is that clear? So, along with this page number, along with the page number, it will add the corresponding process ID of the process. So, with both the parameters, we are going to search in the, okay, inverted page table here. Now, example, let's say, example, look at here, example, we are trying to generate, okay, we are trying to search for page number 5 of process 7, page number 5 of process 7. So, page number 5, you directly take from the logical address, page number you take from the logical address, and process ID will be available in the PCB. So, it will take this both the parameters and keep on searching in the, okay, inverted page table here. So, page number 5 of process 7. So, keep on searching here, page number 5, process 7, is it matching here? Okay, no, it is not matching. So, page number 5 of process 7, okay, is it matching here? Yes, sir. Okay, it is matching here. Okay, page number 5 of process 7, it is matching here. Okay, if it is matching, then you take the corresponding, okay, frame number. Okay, you take the corresponding frame number, okay, and you generate the physical address. Is that clear? So, it means what? Page number 5 of process 7 is available in the frame number 7, frame number 7. So, ultimate goal is to find out what? Frame number only, because the frame number will tell you, batao, frame number will tell you, को 2 दिन से बोलते आ रहा हूँ, okay, frame number will tell you the physical existence of the page, where the page is actually available in the main memory. So, once you get the frame number, you make the physical address. So, you take the frame number and whatever the D you are having in the logical address, whatever the D you are having in the logical address, you copy the same D from logical address to physical address. You copy the same D from logical address to physical address because page size is same as what? Frame size. So, you copy the same D from logical address to physical address. So, with the help of this frame number, you go to the respective frame in the PIS. With the help of this frame number, you go to the respective frame in the PIS, and with the help of this D, okay, you go to the respective word. Okay, with the help of this frame number, you go to the respective frame here, and with the help of this D, you go to the respective word. Okay, so according to this example, so कौन सा frame में जाना है आपको? Frame number 7. So you go to frame number 7, and with the help of this D, you go to the respective, okay, word here. Okay, so inside that word, you will have what? Actual instruction. Is that clear? Inside that word, you will have the actual instruction. So CPU will fetch that instruction and continue the execution. So, CPU will fetch that instruction and continue the execution. So, this is how, okay, inverted paging will be implemented. Is that clear? Right. So, understand here, if you observe all the points, you are having one more important point in this, one more small important point. Listen here. So, in the inverted paging, okay, understand here, okay, in the inverted paging, we are maintaining only one page table for all the process. Listen here. Because we are maintaining only one page table, for all the processes, okay, so that is the reason the memory required to maintain the page tables of the processes, will be less. Memory required to maintain page tables of the process will be less, but the searching time for the corresponding page of a process, will be less. Okay, memory required, memory required to maintain the page tables of the process will be less. But searching time for the corresponding page of a process will be what? More. Searching time will be more because सारे process का pages एक ही page table के अंदर है. So searching time for the corresponding page of a process will be what? More. ज़्यादा time, searching time ज़्यादा होगा. Is that clear? So I am repeating once again. Okay, the answer सुनो. Because we are maintaining only one page table for all the processes. Because we are maintaining only one page table for all the processes, the memory required to maintain the page tables of the processes will be less. Okay, but the searching time for the corresponding page of a process will be what? More. Searching time बहुत ज़्यादा होगा. Is that clear? Right. क्योंकि एक ही पेज टेबल के अंदर सारे पेजेस अपन स्टोर कर रहे हैं. So मेमोरी तो कम होगा, okay, मगर सर्चिंग टाइम बढ़ेगा. Is that clear? Note down this point. The memory required the memory required to maintain the page tables of the processes will be less. The memory required to maintain page tables of the process will be less, but the searching time for the corresponding page of a process will be more. Searching time for the corresponding page of a process will be more. Okay, full stop. Right. So understand here. So what are the important points? That's it. Okay, itna hi hai. Simple hai. Inverted paging is very simple. Okay, so nothing complicated in this. Now what is the only important point? Very very important point to remember. Jo dabba mein likhe aap log. Okay. So now what is the important point here? Number of entries in the inverted page table. Okay, is same as what? Number of frames in the PAS. Is that clear? So that is one of the important point you should remember. Okay. Right. Note down. Let's solve the questions. Okay, everything follows a question. जो भी मैं पढ़ाऊंगा immediately question होता है. Okay, so you need to be very alert and careful when you are listening. Okay, note down the question. Consider a system which has okay, all of you copied this example. इसको copy किए थे क्या? Okay, ये वाला please diagram के बाजू में इसको copy किए सब लोग? कॉपी करो इसको. कॉपी नहीं करे तो कॉपी करो. Okay, please copy this as an example. Okay, so I'm removing this. Okay, next note down this. Consider a system which has a logical address of 34 bits. So I'm writing here logical address of 34 bits. Logical address of 34 bits and physical address of 29 bits. Physical address of 29 bits. Physical address of 29 bits. Page size of 16 KB. Page size of 16 KB and memory is byte addressable. And page table entry size is 8 bytes. यहाँ पे लिखा है page table entry size. Okay, is 8 bytes. Page table entry size is 8 bytes. Then calculate question number 1. Calculate question number 1. The conventional page table size. Conventional मतलब क्या है? Normal page table. Conventional page table size. Question number 2. Inverted page table size. Okay, right. So just listen here. Conventional page table means what? Normal page table. दोनों में difference क्या है? What is the difference between these two questions here? In the conventional page table, number of entries is same as what? Number of pages in the LES. But in the inverted page table, okay, inverted page table, what's the difference here? Inverted paging, number of entries will be same as number of frames in the PAS. So that is the difference, okay, between two questions. Now remember, page table entry size directly given to you. Page table entry size is directly given to you. So no need to think anything. So we simply directly multiply with the page table entry size. Entry size तो दे दिया, सीधा आपको multiply करना है. इज लिया. So कुछ भी सोचने का नहीं है. Entry size दे दिया आपको simply multiply करना है. So solve that questions. Those two questions. I'll wait 5 seconds in the live. Pause करो, वीडियो पास करो. जब भी मैं पास करने को बोलता हूं तो पास करना है तुरंत. Okay. Now, so I'm assuming all of you solved. So let's see. So first question क्या है? First question, conventional page table size. Conventional page table size. Okay, same formula. Number of entries multiply with the entry size. Okay, number of entries in the conventional page table same as. Okay, now look at here. 2 power. Okay, number of entries same as number of pages. So 2 power 34 divided by. Okay, 2 power 14. Okay, multiply with what? Entry size. Okay, 8 bytes. Okay, so understand here. So this how much here total? 2 power 20 multiply with the 8 bytes. So that is how much here? 8 megabytes. 8 megabytes. So that is the question number 1. So next. Okay. So next question number 2. Question number 2. Okay, ये तो simple है, ये तो कल का क्लास ही है, right? Number of entries multiply with entry size. Number of entries same as number of pages. Simple. Okay, so alias divided by page size. समझ आया ना सब लोग? Now, okay, next is what? Inverted page table size. Inverted page table size. Okay, what is the formula? Same formula. Number of entries. Okay, in a inverted page table multiply with what? Page table entry size. Page table entry size. So number of entries in the inverted page table. This is how much here? Number of frames. मैं यहाँ पे अच्छे से लिख रहा हूँ. Okay, number of frames in PIS. Number of frames in PIS. Okay. So now tell me number of frames कैसे आएगा? 2 power 29. Okay, PA कितना दिया? 29 bits, right? Okay, 2 power 29 divided by page size, frame size both are same. So that is 2 power 14. Multiply with the entry size, that is 8 bytes. So entry size दे दिया आपको सीधा. Okay, कुछ भी करने का नहीं है, सीधा multiply करना है. So 2 power 29 divided by 2 power 14 multiply with 8 bytes. So this is 2 power 15. Okay, correct? 15 है ना? And 2 power 3 bytes. That is 2 power 18 bytes. 2 power 18 is how much? 256 kilobytes. Correct? 256 kilobytes. सही है ना calculation? Right. So if any printing mistake is there, so please make the correction. अगर कुछ okay printing mistake हो जाता है कभी कभी. Okay, right? So okay, please check it out. So right answer is okay, this one is 256 kilobytes and this was the 8 megabytes. Is that clear? So that is the okay first question. Is that clear for everyone? Right. So simple question है, right? So next let's solve the next question. Go to your workbook. Workbook निकालो. Go to your workbook. Page number 106. Page number यहाँ पे लिख रहा हूँ. Page number 106. Question number 23. Page number 106. Question number 23. Now in the question, the small pointer. Okay, he has given RAM. Okay, RAM is given to you. Consider RAM of 128 KB. RAM means okay, LAS or PAS? PAS. RAM means PAS. Okay, so pass करो, video pass करो. I'll wait 5 seconds. Page number 106, question number 23. Solve that question. Virtual address means what? Okay, logical address only. Okay, right. So solve किए सब लोग. Right. Right answer is what? A. A is the right answer. Okay. A for Ahmedabad. Okay. A is the right answer. Now is asking you to find out what? Okay. Ratio of the page table and inverted page table. Right. Simple. Okay. Ratio of a page table size. Okay. Ratio inverted page table size. So this is what is asking. So page table size. Okay. Page table means what? Normal page table. Normal page table. Logical address कितना दिया? 32 bits. Page size 4 KB. So look at here. So 32 bits. 2 power 30 divided by 2 power 12. So okay, page table size. Okay, same thing. Number of entries multiply with the entry size. Okay, entry size 4 bytes. Number of entries multiply with entry size. Okay, normal page table size. Okay, right. Inverted page table. Number of normal page table number of entries same as number of pages, right? So inverted page table, same thing. Number of entries multiply with entry size. Number of entries same as number of frames. Number of frames 2 power 17 PAS divided by frame size. So okay, 2 power 17 PAS कितना दिया? Okay, RAM 128 KB मतलब 2 power 17 हो गया. Multiply with entry size कितना दिया? 4 bytes. So no problem. Okay, इधर भी 4 bytes cancel. So इसका वैल्यू निकालो. रेशो ये कितना आ रहा है बताओ? 2 power 20 आया. हाँ, इसको डिवाइड कर तो कितना होगा? 2 power 5. सो 2 power 5 मल्टीप्लाई 1 मल्टीप्लाई विद 1 लिख सकते हैं, राइट. सो ये 2 power 5 कैंसिल, यहाँ पे कितना बचेगा? 15. सो 2 power 15 रेशो 1. ओके, सो दिस इज अ ओके राइट आंसर. क्वेश्चन नंबर 23. राइट आंसर इज अ ए. ए इज द राइट आंसर. ओके, so if anybody want to copy, okay, you can copy that. Okay, next, so let's move on to the next question. Page number, okay, 104. Okay, this is the good question. Page number 104, question number 5. 104, question number 5 यहाँ पे लिखा है. पेज नंबर 104 ओनली. ओके, मेमोरी का. ओके, मेमोरी का चैप्टर में. सो क्वेश्चन नंबर 5. सो दैट इज वन ऑफ द गुड क्वेश्चन. ओके, अच्छा क्वेश्चन है, सोच के करो. अच्छा क्वेश्चन है बोला. दैट इज रियली गुड क्वेश्चन. थिंक केयरफुली एंड सॉल्व. पेज साइज इज गिवन एज 4 KB. 4 KB पेजेस दिया है. 4 KB पेजेस मतलब क्या है? वो पेज साइज है, राइट. सो थिंक केयरफुली एंड सॉल्व. पास करो, वीडियो पास करो. पास करने को बोले तो पास करो बस. गलत भी हो सही हो, सब कुछ सॉल्व करना ही करना है. सो इज अ राइट सॉल्यूशन और राइट और रॉन्ग. सो प्लीज ट्राई टू सॉल्व दैट. सिंसियरली सॉल्व द प्रॉब्लम. गलत भी होने दो, कोई प्रॉब्लम नहीं है. आप रेक्टिफाई कर सकते हैं मिस्टेक कहां पे हो रहा है. पास करके सॉल्व करना. ओके, राइट. सो पेज नंबर 104, क्वेश्चन नंबर 5. सो लेट्स डिस्कस दैट. सो राइट आंसर इज, शैल आई रिवील द आंसर? राइट आंसर इज बी फॉर बॉम्बे. बी इज द राइट आंसर. ओके, सो देखते हैं कितने लोगों का सही हुआ, कितने लोगों का सही नहीं हुआ. ओके, जस्ट लिसन हियर. ओके, so is asking you to find out what? Okay, inverted page table size. Inverted page table size आपको निकालने को बोल रहा है. So inverted page table size means what? Same formula, number of entries in a inverted page table multiply with what? Page table entry size. Page table entry size. So number of entries in the inverted page table, this is same as what? Number of frames. ओके, जब से बोल रहा हूं नंबर ऑफ फ्रेम्स. बताओ नंबर ऑफ फ्रेम्स कैसे आएगा? 2 power 30 डिवाइडेड बाय 2 power 12. ओके, PAS डिवाइडेड बाय फ्रेम साइज और पेज साइज. सो मल्टीप्लाई विद व्हाट? एंट्री साइज. लिसन केयरफुली. ओके, ये वाला समझ में आया, राइट. नंबर ऑफ एंट्रीज इन द इन्वर्टेड पेज टेबल सेम एज नंबर ऑफ फ्रेम्स. नंबर ऑफ फ्रेम्स कैसे आएगा? PAS डिवाइडेड बाय फ्रेम साइज. ये तो कल का क्लास ही है, फर्स्ट क्लास पेजिंग का ही है. सो PA कितना दिया? 30 बिट्स दिया था, राइट. So okay, 30-bit byte addressable physical address. Okay, so now look at here. So this is the PAS divided by okay frame size. So now next यहाँ पे गलत कर रहे हैं बहुत लोग. पेज टेबल एंट्री साइज आपको नहीं दिया, पेज टेबल एंट्री साइज नहीं दिया. क्या बोल रहा है क्वेश्चन में ओके पेज टेबल एंट्री कंटेन्स ओके पेज नंबर प्लस 12 ओवरहेड बिट्स. ये आपको बताया. नाउ अंडरस्टैंड हियर. ओके page table entry contains what? Page table entry contains okay page table entry contains page number plus 12 overhead bits. Page number plus 12 overhead bits. Understand here. So page number plus 12 overhead bits. Okay, so is doing this. Okay, understand here. ये 12 ओवरहेड बिट्स किस लिए दिया गया? मे बी दिस इज फॉर व्हाट? प्रोसेस आईडी. लुक एट हियर, पेज टेबल एंट्री में क्या है? देखो पेज नंबर है और प्रोसेस आईडी है. सो ये 12 ओवरहेड बिट्स जो दिया गया दैट इज मे बी फॉर व्हाट? प्रोसेस आईडी. सो बस आपको ये निकालना है पेज नंबर रिक्वायर्स हाउ मेनी बिट्स. दिस इज व्हाट यू नीड टू फाइंड आउट. क्वेश्चन में क्लियरली बताया पेज टेबल एंट्री कंटेन्स व्हाट? पेज नंबर प्लस 12 ओवरहेड बिट्स. सो पेज नंबर रिक्वायर्स हाउ मेनी बिट्स. सो दैट इज व्हाट यू नीड टू फाइंड आउट. नाउ टेल मी पेज नंबर के लिए कितना बिट्स चाहिए? How many bits are required for the page number? How we will get that? How we will get? You need to find out number of pages. Okay, you need to find out number of pages. Okay, so I am finding here. So look at here. So you need to find out number of pages. Okay, now tell me number of pages. So how we will find out number of pages? Number of pages same first day class of paging. Number of pages LAS divided by page size. LA कितना दिया? 32 bits. 2 power 32 divided by 2 power 12. Page size, frame size both are same. So this is the number of pages. That is how much? 2 power 20. So if the number of pages are 2 power 20, if the number of pages are 2 power 20, then page number requires how many bits? If the number of pages is 2 power 20, if the number of pages is 2 power 20, then page number requires how many bits? Page number requires how many bits? 20 bits. Okay, very good. So now come back to this. So this is how much here? Okay, 2 power 18. ओके 30 माइनस 12 2 पावर 18. पेज नंबर के लिए 20 बिट चाहिए प्लस 12 ओवरहेड बिट्स हैं. ओके नाउ टेल मी पूरा मिलाए तो कितना होगा? 2 पावर 18 मल्टीप्लाई विद पूरा मिलाए तो कितना बिट्स होगा? 32 बिट्स होगा. 32 बिट्स होगा. 2 पावर 18 and 32 bits is equal to how many bytes? 32 bits is equal to how many bytes? 4 bytes. So 2 power 18 multiply with the 4 bytes. That is 2 power 18 multiply with 2 power 2 bytes. That is 2 power 20 bytes. 2 power 20 bytes. Okay, 32 bits is equal to 4 bytes. So 4 bytes is a 2 power 2. 2 power 18, 2 power 2. That is 2 power 20. So 2 power 20 bytes. Is that clear for everyone? So this is how okay you need to solve the problem. Is that clear? So that is the okay concept of इन्वर्टेड पेजिंग. इज दैट क्लियर फॉर एवरीवन? ओके, बहुत लोग यहाँ पे मिस्टेक करते. ओके, जो लोग किया है यहाँ पे मिस्टेक करते. देखो यहाँ पे क्या मिस्टेक करते बहुत लोग, ये 32 बिट्स को क्या कर लेते सब लोग? 2 पावर 5 ले लेते. सो मेनी पीपल विल डू द मिस्टेक. ओके, 32 यू राइट इट एज 2 पावर 5. So even if you write that as 2 power 5, your answer will be in what? Bits. Your answer will be in the bits. But what is the option given there? In bytes. Option is given in the form of bytes, right? So don't do that silly mistake. Okay. So if you do that simple and silly mistake, you get the wrong answer, right? So that is the okay concept of inverted paging. Okay, with all the related questions. Is that clear? Right. So thank you. So dear students, next in the continuation we will move on to the next topic, that is segmentation. So what is the meaning of segmentation and how we are going to implement segmentation? Let's try to understand here. So before that, okay, you need to copy the diagram. Okay, so diagram will be lengthy. Okay, same thing, notes को turn करके fresh page में copy करो. Notes को turn करके fresh page में copy करो. So please copy this. नोट्स को टर्न करके फ्रेश पेज में कॉपी करो. Okay, so I think now you can start. So somebody just waiting, okay, to check how large is the diagram, right? मुझे पता है, okay, कुछ लोग बस ऐसे वेट कर रहे हैं कि कितना बड़ा है देखते उसके बाद बनाते, हाँ, right? So now you can copy. I'll fill the values. So please copy this fast. 7,000, 5,800. So I think you can copy. Okay, so this is like square root function, GCD function, some K function, addition function, it's a subtraction function. Okay, so these are the segments. LAS is divided into segments. Okay, so it's a segment 0, segment 1, segment 2, segment 3, segment 4 and segment 5. So please copy this carefully, understand and make the proper diagram. So I will wait 5 seconds in the live. I'll say wait 5 seconds in the live. Okay, so let's move on to this. So what is the meaning of segmentation? Let's try to understand. So if anybody is still copying, then you can pause the video. Okay, so please pause the video and try to copy. So why we are going for segmentation? First of all, okay, what is the need of segmentation? Let us try to understand that. Okay, why we are going for segmentation? The answer is not just say, listen to me carefully. Why we are going for segmentation? The problem in the paging is, the paging does not follow user's view of memory allocation. The problem in the paging is what? Paging does not follow user's view of memory allocation. बताओ यूजर्स व्यू मतलब क्या होता है? यूजर्स व्यू मतलब आई एम टॉकिंग अबाउट दिस वन. ओके, लुक एट हियर. सो यूजर्स व्यू ऑफ मेमोरी एलोकेशन. व्यू मीन्स ओके लाइक जैसा यूजर सोचता है ऐसा नहीं होगा. ओके, यूजर इन द सेंस व्हाट? प्रोग्रामर. ऑब्वियस यूजर मतलब प्रोग्रामर. So, okay, paging does not follow users view of memory allocation. So, users view of memory allocation. Understand here, users view मतलब क्या है? Programmers view. So, what is the programmers view? Okay, programmers view क्या होता है? Like for example, you are writing any some program. Let's say, okay, you are writing some simple C language program or Java program, whatever you take. So, generally, your program will contain what? Various set of methods, various functions, or you say, okay, various modules. So, you have something like okay, main function, you are having GCD function, okay, like you are having square root function, you are having some addition function, okay, you are having different functions in your program, okay, functions in your program. So, as a common user, common programmer, you may feel like, okay, add function will be stored somewhere in the memory, subtraction function will be stored somewhere in the memory. Now, look at here, main function will be stored somewhere in the memory. So, as a programmer, you may feel like this. But remember, that is not going to happen in the paging. That is not going to happen in the paging. Paging में ऐसा नहीं होगा. Paging में कैसे होगा? Paging में कैसे होगा? Paging simply divides the program into equal size pages. So, it does not bother where your function is starting, where your function is ending. So, it simply divides the program into equal size pages. So, page size will be already predefined in the operating system. Okay, वो page size लेके so directly क्या करेगा वो? Okay, simply divide करेगा, okay, into pages. So, it simply divides the program into equal size pages. It doesn't bother where your function is starting, where your function is ending. Okay, so paging does not follow user's view of memory allocation. यूजर जैसा सोचता है ऐसा अलोकेशन पेजिंग में नहीं होगा. पेजिंग में कैसे होगा? ओके, ऑलरेडी टोल्ड. पेजिंग में कैसे होगा? इट सिंपली डिवाइड्स द प्रोग्राम इनटू इक्वल साइज पेजेस. ओके, इट डजंट बॉदर वेयर योर फंक्शन इज स्टार्टिंग, वेयर योर फंक्शन इज एंडिंग. सो दैट इज द रीजन टू अचीव यूजर्स व्यू ऑफ मेमोरी एलोकेशन. The concept of segmentation is implemented. The answer is not say, okay, to achieve user's view of memory allocation, the concept of segmentation is implemented. In the segmentation, LAS, logical address space, will be divided into various segments. Okay, in the segmentation, LAS, logical address space, will be divided into various segments. Okay, look at it, divided into various segments, like main function as one segment, square root function as one segment, GCD function as one segment, like this different function as a different segment. Okay, it is going to divide like that. So, it means what? Okay, it is following user's view of memory allocation. So, as a user, you may feel like, okay, ऐसा सोचते हैं कि okay, add function एक जगह होगा, main function एक जगह होगा, GCD function एक जगह होगा. So, that is going to happen in the segmentation. Okay, but that is not going to happen in the paging. Is that clear? So, मैं repeat कर रहा हूँ फिर से all the points. Why we are going for paging? Paging does not follow user's view of memory allocation. To achieve a user's view of memory allocation, the concept of segmentation will be implemented. So, in the segmentation, LAS will be divided into what? Various segments. Is that clear? Note down all the points one by one. Make a proper notes. Note down. First point, the paging does not follow. User's view of memory allocation. Paging does not follow user's view of memory allocation. Paging does not follow user's view of memory allocation, full stop. Next, second point, to achieve user's view of memory allocation, to achieve users view of memory allocation, the concept of segmentation is implemented. To achieve users view of memory allocation, the concept of segmentation will be implemented. Note down next point. In the segmentation, LAS, logical address space, LAS will be divided into various segments. LAS will be divided into various segments. Okay, full stop. Now next, when you say LAS is joined to various segments, just listen carefully. When you say LAS is joined to various segments, the segments of LAS will vary in the size. Okay, important point. The answer सुनो. Okay, जब बोला कि okay, LAS is divided to various segments. Okay, मतलब main function has one segment, GCD function has one segment, addition function has one segment, like this. So when you are dividing like that, okay, different function has a different segment. Obviously, the segments of LAS will vary in the size. Vary मतलब क्या है? अलग-अलग. Okay, अलग-अलग होगा. इसलिए different okay होगा. इसलिए they vary in the size. Is that clear for everyone? Right. So understand here. So segments of LAS will vary in the size. Okay. So अलग-अलग होगा. Is that clear? Note down this point. Note down. The segments of LAS will vary in the size. Vary in the size मतलब variable size होगा, अलग-अलग size होगा, different size होगा, vary in the size. Now tell me, okay, important point, यहाँ पे segments of LAS will vary in the size, but coming to the pages, paging में pages of LAS will be equal in the size. Is that clear for everyone? Right. Okay. So next, note down next point लिखो. Segments of LAS will be brought into PAS. Segments of LAS will be brought into PAS. Right. So understand here. So segments of LAS will be brought into PAS. Okay. देखो यहाँ पे segments of LAS. So segment number 3, segment number 2, segments of LAS will be brought into PAS. So paging में क्या होता है? Paging में same thing. Pages of LAS will be brought into PAS. वहाँ पे paging में. So यहाँ पे segments of LAS will be brought into PAS. Is that clear for everyone? Right. Okay. So next. So I am coming from the first. Okay. The answer सुनो अच्छे से. So this is the okay, very simple and easy. So it is not complicated. So very simple and easy. Now, so understand here. So CPU always generates logical address. So P means what? Same thing. Processor always generates a logical address. So processor always generates logical address. Now here, okay, in the segmentation, logical address divided to what? S and D here. The answer सुनो अच्छे से. Logical address divided to what? S and D. So okay, but paging में it is divided to what? P and D. So but here it is divided to S and D. What is the meaning of S? Okay, note down. Next, S equal to number of bits required to represent segments of LAS. Number of bits required to represent segments of LAS or segment number. Or segment number. Okay, full stop. So it means indirectly S will tell you what? Segment number. Next is what here? D. So what is the meaning of D? Okay, note down. ऐसा लिखो, D equal to number of bits required. D equal to number of bits required to represent number of bits required to represent segment size. Number of bits required to represent segment size. और लिखो, ऐसा लिखो, or word number of the segment. Word number of the segment. Okay, word number of the segment. And one more R. Word more R is, okay, it is also called as what? Segment offset. It is also called as a segment offset. Okay. So, meaning of all that is the same only. Okay. Meaning of all that is the same. Right. Okay. Right. So, understand here. Okay. So, the answer is no, that is a segment offset. So, understand here next. Okay. So, D will, this will tell you segment number and D will tell you what? Segment offset. Is that clear? So, I am repeating, S will tell you segment number, D will tell you segment offset. Okay, word number inside the segment. Now, in the segmentation, we are maintaining something called segment table here. Okay, we are maintaining something called segment table. What is the meaning of segment table? Okay, let's try to understand here. So, in the segment table, first important point, how many entries are there? How many entries are there? Batao. Okay, how many entries are there? 5 bol raha hai koi log? 5. Okay, 0 to 5, 6. Okay, 6 entries are there. So, copy karo. So, this is the segment number. Okay, this is the segment number. That's the segment number. Now, in the segment table, you are having how many entries here? Okay, 6 entries are there. Okay, so 0 to 5, total 6 entries are there. So, why you are having 6 entries? Because that is same as number of segments in the LAS. That is same as number of segments in the LAS. Now tell me how many segments are there in the LAS? 6. 1, 2, 3, 4, 5, 6. 6 segments are there. So that is the reason how many entries are there? 6 entries are there. So note down this point. Note down this point. Number of entries in the segment table. Number of entries in the segment table is same as, लिख सकते हैं आप, पूछ से लिख सकते हैं, नंबर ऑफ एंट्रीज इन द सेगमेंट टेबल इज सेम एज नंबर ऑफ सेगमेंट्स इन द LAS. Now, okay, so what is that you have written? So number of entries in the segment table. Number of entries in the segment table is same as what? Number of segments in the LAS, right? So next, now understand here. So in the segment table, you are having two parameters here. So just listen carefully. Segment table entry. In the segment table entry, you are having two parameters. So BA. So BA means what? Base address. Okay, note down. Copy karo. BA means what? Base address. And next is what? Size. Size is also called as length of the segment, or sometimes it is also called as limit of the segment. Sorry. Okay. So it is called as the length of the segment or limit of the segment. Copy karo. Now understand here what is the meaning of this okay, base address and size or length or limit or okay, let's try to understand. So segment number 0 base address मतलब क्या है? Starting address. Okay, base address is 3600 and size is how much here? 300. So check करो PS में, देखो यहाँ पे PS में segment number 1 कहाँ पे है? यहाँ पे. Okay, look at here, segment number 1 segment number 0, sorry, segment number 0, right? Segment number 0. Okay, base address is 3600 and size is what? 300. Segment number 0 का. So देखो यहाँ पे segment number 0 base address is 3600, starting address 3600 to 3900. So how much is the size? Size कितना हो गया? 300 ही तो हुआ, right? 3600 to 3900. So size is a 300. Okay, that is the size. So you can check anything. Let's say segment number 5. सुनो इधर segment number 5 का देखो. Segment number 5 का base address is 9000. Size is how much here? 500. So देखो segment number 5 का base address is 9000. 9000 to 9500. 9000 to 9500. तो साइज कितना हो गया? बताओ इसका 500 हो गया, राइट? So you are maintaining two parameters in the page table entry, that is the base address of the corresponding segment and the size, okay, size of the corresponding segment. So let us say, okay, you want to search for, okay, you want to refer any particular segment. Listen here, if the CPU is trying to access, okay, segment number 3, just say example. Example, CPU is trying to access the segment number 3. So you take that segment number, okay, index onto the segment table. Okay, you take that segment number, index onto the segment table. Okay, you take that segment, okay, segment number, index on the segment table here. Inside the segment table entry, you are having two parameters. One is the base address of the segment and next is the size or length, or you say limit of the segment. So you take this length of the segment here and you take the offset value, whatever the D value you are having, you take the D value and you are doing the comparison. So look at here, okay, D less than L होना चाहिए या L less than D होना चाहिए. The answer सुनो इधर, D will tell you what? बताओ, D क्या बताएगा? D will tell you offset. Offset मतलब क्या है? Word number inside the segment. Okay, D मतलब क्या है? Word number inside the segment. Is that clear? So D will tell you the word number inside the segment and L will tell you what? Total length of the segment, or you say size of the segment. So L will tell you total length of the segment and D will tell you the word number inside the segment. Now tell me what should be the relation between these two things here? ये दोनों में relation क्या होना चाहिए? D less than L होना चाहिए या तो L less than D होना चाहिए? सोच के बताओ. D less than L होना, L less than D होना? हाँ, stupid fellows. Okay, कुछ लोग गलत बोल रहे हैं. So क्या होना चाहिए? D less than L होना चाहिए. Okay, so this is the relation you need to follow. So D less than L होना चाहिए. Is that clear? So D less than L क्यों होना चाहिए? What is the meaning of that? इसका मतलब क्या है? The answer सुनो इधर. So D less than L क्यों होना चाहिए? Listen here. Okay. So let's say, okay, example 1 ना. Okay, आप लोग बाद में copy करो. So पहले सुनो. Okay, you can copy that later. So let's say for example, I am referring segment number 3. Let's say S equal to 3. Let's say example D value coming as a 210. Just say example. D value coming as a 210. So segment number 3 I am trying to refer, D value coming as a 210. Now you do the comparison. D less than L होना चाहिए. So okay, D should be less than L. Now tell me what is the D value? 210. Okay, and what is the length of the segment? Segment number 3 का L कितना है? 200. देखो segment number 3 का length कितना है? 200 है. So now you check the comparison. D less than L. So 210 less than 200. Now tell me, is it a true or false? False. Now remember, okay, 210 less than 200, this is false. What is the meaning of this? Okay, that means segment number 3 is having total length of only 200 words. Segment number 3 is having total length of only 200 words. But you are trying to refer the word number 210. You are trying to refer word number 210. It means what? You are referring outside the segment. You are referring outside the segment, or you say beyond the segment, or illegal address. Illegal address. Is that clear? So uske andar to it is having only 200 words, but you are trying to refer word number 210. So how that is possible? So that is an illegal address. If you want to refer, you should refer only within the segment. Okay, limit of the segment. Okay, so but understand here. So when you say D less than L, if this condition is not followed, look at here, D less than L. If the condition is not followed, if it is no, then what happens? The trap to the operating system. Trap will be generated to operating system. So it means what? Signal will be sent to operating system. Signal will be sent to operating system. Okay, saying that okay, CPU is referring illegal address. Okay, or you say outside the segment or beyond the segment. Is that clear? Right? So look at here. So 210 less than 200. If it is false, okay, what happens here? Now tell me. Trap to the operating system. So trap will be generated to operating system. Okay. So next, let us say for example, if the condition is followed, D less than L, if the condition is followed. So let's take next example. Okay, listen here. So same thing. Okay, so segment number 3 here and D value coming as 190 and L is how much here? 200. Okay, so same thing. Segment number 3 का length कितना है? 200 है. Length कितना है? 200 है. Okay, so D value coming as 190 here. Now same thing, you do the comparison. D less than L होना चाहिए. D less than L होना चाहिए. Now D less than L. Okay, 190 less than 200. Okay, look at here. 190 less than 200. Now tell me, is the condition satisfied here? Yes. Okay, 190 less than 200. Okay, that is true here. Okay, if it is true, it means what? Whatever the word number you are trying to refer. whatever the word number the CPU is trying to refer, so that is within the length of the segment. Whatever the word number you are trying to refer, that is within the length of the segment. So उसका length 200 है, ऐसा 200 length है, okay, जो word number आप refer कर रहे हैं 190, okay, उसके अंदर ही है, okay, that is within the length of the segment. So there is no problem, so that is fine. So it is within the length of the segment. If it is yes, okay, look at here. If it is yes, then what we are going to do here? We are going to take the base address of the corresponding segment. Okay, look at here, the base address of the corresponding segment, and that will be added, okay, along with the offset value. That will be added along with the offset value. So understand here, okay, that will be added. Okay, look at here. So base address will be added with the offset, and you go to the corresponding location in the PAS. You go to corresponding location in the PAS. Okay, now tell me, what is the base address of the corresponding segment? Base address is how much here? 5800. Okay, look at here. So 5800. Okay, plus, okay, D value is how much here? Okay, 190. Okay, and you go to corresponding location the PAS. So you add both of them, 5800 plus 190. So how much is that? 5990. So 5990. So you go to this particular location in the PAS. You go to that particular location in the PAS. So is that clear for everyone? Right? Okay. Now understand here. So this is how, okay, you are going to generate the, okay, corresponding, okay, from logical address to physical address. So look at here. So 5990. So if you add these two things, 5800 plus 190, 5990. So you go to corresponding location. Look at here. ये दोनों add किया, D value add किया, base address add किया, तो 5990 आया. So 5990. You go to that particular word. So where is that word here? 5990. So it will be somewhere here. In the segment number 3, 5990. You go to this particular word. Okay, so CPU will go to that particular word, and inside that word, you will have the actual instruction of the process, and the CPU will fetch that instruction. And continue the execution. Is that clear? So this is how the segmentation will be implemented. Is that clear for everyone? So I am just repeating all the points here. So what is more important here is only two things. Okay, D less than L, ये condition होना चाहिए. So whatever the word number you are trying to refer, that should be within the length of the segment. So D less than L should be followed. If it is not followed, then it means what? You are referring outside the segment or beyond the segment, illegal address. So in that case, the trap will be generated to operating system. Trap in the sense like signal. Okay, right? So okay, then generated to OS. If it is yes, if the D less than L is okay, condition is followed, then what happens? You take the base address of the corresponding segment, and that will be added with the offset value, and you add both of them, and you go to corresponding location in the PAS. Is that clear? So this is how, okay, this is how segmentation will be implemented. Next, so in this you will have the, okay, two, okay, important points. Okay, small one doubt is a small doubt. So somebody think like, okay sir, D less than L, why it is D less than L? It should be like less than or equal to. Okay, somebody may think like this. Now remember, it cannot be less than or equal to. Why? Because, okay, if the, okay, length is, for example, 200 words is there. If you are having 200 words, so total 200 words are there, means numbering will start with what? 0 to what? 199. Is that clear? So if you are having total 200 words, so word number 0 to 199 you will have. So okay, it means, okay, it should not be less than or equal to. Okay, so it is only what? Less than you hona chahiye. Is that clear for everyone? Because somebody, okay, may think, okay, less than or equal to hona chahiye. So that is the reason I am giving that. So okay, ये तो समझ में आ जाएगा ना? No need to copy this. Okay, right? You can understand that. And the next important point here, listen carefully. Next important point, you should make the guess. Actually, you should have an idea about this point. Okay, I gave you the reasonable hint, okay, to guess this point. Now, what is the important point here? I told you that clearly, LEAS will be divided into various segments. And the segments of LEAS will vary in the size. When I say the segments of LEAS will vary in the size, listen here, variable size segments, अलग-अलग size का, variable size segments are brought from LEAS to PAS. Variable size segments are brought from LAS to PAS. So it means it is similarly behaving like, इसको देखे तो मालूम होना चाहिए, it is similarly behaving like variable partition scheme. It is similarly behaving like a variable partition scheme. It means okay, segmentation still suffers from external fragmentation. Segmentation still suffers from external fragmentation. So ये बहुत important point है. Okay, so this very very important point, and you should have the idea, okay, before I explain. Okay, so if anybody thought of this point, so that is really good thinking. Okay, so that is really good thinking. Okay, make a note of this point. Make a note of this point first. Note down the variable size segments. The variable size segments are brought from LAS to PAS. The variable size segments are brought from LAS to PAS. So it is similarly behaving like variable partition scheme. So it is similarly behaving like a variable partition scheme. Hence segmentation still suffers from external fragmentation. Segmentation still suffers from external fragmentation. Segmentation still suffers from external fragmentation. Okay, so I have written there. Okay. Okay, so copy these two examples. ये दो examples copy किए सब लोग. Okay, example 1, example 2. Please copy this. So my side हो जा रहा हूँ. Okay, you can pass. ये दोनों copy करो. Example 1, example 2, copy this. And ये भी copy किया. Length limit यहाँ पे ये copy किया. D less than L. Copy करो. कुछ लोग तो ऐसे ही देखते रहते. Right? D less than ये copy करो. ये copy करो. ये examples copy करो. You can pause my video and copy. Okay. So fine. So let's take up some question, right? So go to your workbook. So workbook पे जाइए. So please go to workbook. Let's solve some question. Page number 106. Question number 24. Page number 106. Question number 24. Page number 106, question number 24. So please read the question and try to solve. Okay, so page number 106, question number 24. पास करके सॉल्व करो. Right, हो गया सबका. So what is the right answer? Right answer is A. A is the right answer. Okay, listen here. So he is having 3 and 222. Okay, this is the logical address he is having. So he is asking you to find out what corresponding physical address. So 3 and 222, okay, you have to consider this as a S and this as a D here. So this is a segment number and this is a D, okay, segment offset. Okay, now he is asking you to find out, okay, understand here, corresponding complete physical address for the logical address. So if you want to generate the physical address for anything, so first you do the comparison. D less than L होना चाहिए. So D should be less than L, okay, D less than L होना चाहिए. So अगर D लेस देन L हो रहा है, ओके, देखो यहाँ पे D का वैल्यू देखो, D लेस देन L होना चाहिए. सो ध्यान से सुनो, डी वैल्यू कितना है बताओ 222 एंड एल वैल्यू कितना है बताओ, सेगमेंट नंबर 3 का लेंथ कितना दिया, लेंथ टेबल में दिया, टेबल में सेगमेंट नंबर 3 का लेंथ कितना दिया टेबल में 302, so 322 less than 302. okay, now tell me, so is the condition followed here? Yes, so condition is followed. If the condition followed, then what you will do, base address will be added with the offset value and you go to corresponding location in the PAS. So what is the base address? segment number 3 का base address कितना दिया वहां पे टेबल में दिया, segment number 3 का base address कितना दिया 498. so 498 plus what is the D value? okay, 322. so ये दोनों ऐड करो 498 plus 322, so that is how much here, so 720. okay, 720. so this is the okay right answer. So simple. okay, you just add base address with the corresponding offset value and you go to corresponding location in the PAS. Is that clear? So that's it. okay, that is about segmentation. So segmentation is also very simple and easy, so it is not much complicated or anything. So only important point you should remember, segmentation still suffers from external fragmentation. Is that clear for everyone? Right. okay, fine, that is the segmentation. So let's move on to the next one. So dear students, so we have completed paging, multi-level paging, inverted paging and segmentation. So the last one pending in the okay memory management techniques okay is the segmented paging. So please note down, so keep the heading segmented paging. So this is very important and okay interesting also. okay, so little complicated also, so try to understand all this. So we'll discuss in detail. First copy the diagram carefully. So fresh page में notes को turn करके, fresh page में notes को turn करके diagram अच्छे से बनाओ. okay, right? So I think all are visible properly, right? everything is visible. If anything is not visible or not understandable, you can just leave that, उसको skip कर दो. okay, क्योंकि मैं जब explain करूंगा तब पूरा समझ में आ जाएगा. Is that clear? right. So please copy everything on the board, everything on the board. So मैं थोड़ा 5 seconds के लिए साइड हो जा रहा हूं. So I'll drink some water. okay, so copy the diagram. आप लोग पास करो, वीडियो पास करके पूरा अच्छे से कॉपी करो. So please pause the video and try to copy the entire diagram. Make a proper diagram. Okay, so right, understand here, I think all of you copied, so I am assuming all of you copied. Diagram तो copy किए सब लोग, right? So next okay, we'll move on to the next one, the okay segmented paging. ध्यान से सुनो अच्छे से, पूरा अच्छे से ध्यान से सुनो. okay, obviously after my concept explanation you need to okay solve the problems, obviously, right? right. So next we'll move on to the next one. okay, that is a segmented paging. So this is the combination of both paging and segmentation. So this is a combination of both paging and segmentation. Listen carefully. So I am assuming logical address is 34 bits. Just listen first. Logical address copy किया ना सब लोग इसको, right? Logical address has 34 bits and logical address will be divided into what? Two parts, S and D here. And I assumed S equal to 16 bits and D equal to S equal to 18 bits and D equal to 16 bits. Now understand here, so CPU always generates logical address, P means processor, okay, that generates logical address. I assumed the logical address has 34 bits and logical address will be divided to S and D. ये तो normal segmentation की बात कर रहा हूँ, normal segmentation में, right, जो अपन okay previously पढ़े. So in the normal segmentation, okay, that's divided to two parts, S and D. S is 18 bits and D is 16 bits. Now tell me, segment number requires 18 bits लिखा है. Segment number requires 18 bits. If the segment number requires 18 bits, maximum you will have how many segments? Segment number के लिए 18 bits चाहिए, तो maximum how many segments you can have? 2 power 18 segments we can have. Okay, look at here. In the LEAS, you can have maximum 2 power 18 segments. So please copy this. 0, 1, 2, 3, 4. like this 0 to 2 power 18 okay minus 1 segments. So 0 to 2 power 18 minus 1 segments will be there. So if you are having total 2 power 18 segments, okay, then obviously segment table entries. Segment table will have how many entries here? 2 power 18 entries, okay, like this. So 0, 1, 2, 3, 4, 5, okay, like this 0 to 2 power 18 minus 1, okay, entries will be there in the segment table. So please copy this also. So segment table, okay, will have 2 power 18 entries, okay, right. Next, now that is about yes. Now tell me D equal to 16 bits. Now tell me if the D is a 16 bits, okay, सोच के बताओ D is a 16 bits है, it means maximum segment size कितना हो सकता है? D अगर 16 bits है, maximum segment size कितना हो सकता है? 2 power 16, is that here? 2 power 16 हो सकता है, right? So maximum segment size, okay, look at here. So I am writing here, so D equal to 16 bits है, तो segment size copy करो, okay, segment size क्या हो सकता है? Okay, 2 power 16 words, that is 64 kilowords, 64 kilowords, okay. So segment size क्या हो सकता है? Maximum 2 power 16 हो सकता है. So 2 power 16 words, I am assuming word addressable memory. So 64 kilowords, okay, it means you are having very large segment like this. Okay, look at here. So you are having very large segment like this, which is having size of 64 kilowords. Okay, so this is a segment size we are having. This is a segment which is having 64 kilowords. Okay, so copy this. Okay, इसको भी copy करो. Copy this segment. Okay, in the previous page or in the next page. Okay, दोनों diagram को mix मत करो. इसको भी कॉपी करना है, दोनों डायग्राम को मिक्स मत करो. कॉपी दिस इन द नेक्स्ट पेज और इन द प्रीवियस पेज. इफ यू हैव a space in the previous page, then you can copy there also, no problem. Otherwise copy in the next page. What is there? कॉपी किया, right? So understand here. So this is the okay segment we are having. Okay, now segment size, maximum segment size कितना हो सकता है? 64 kilowords. Why? Because D के लिए कितना बिट्स अज्यूम किया? D के लिए 16 बिट्स अज्यूम किया. सेगमेंट ऑफसेट के लिए 16 बिट्स अज्यूम किया, तो मैक्सिमम सेगमेंट साइज कितना हो सकता है? 2 power 16. Is that clear? So maximum segment size 2 power 16 हो सकता है. So let's say segment is having something like a 64 kilowords like this. Now remember, in the normal segmentation, जो अपन इससे पहले पढ़े, in the normal segmentation, the entire segment will be brought into main memory. Yes or no, right? In the normal segmentation, entire segment will be brought into main memory. Okay, you can see that. Okay, previous diagram पे जाओ, segmentation का diagram में देखो, टर्न करो, पेजेस टर्न करो, सेगमेंटेशन का ओके डायग्राम देखो. हाँ, सेगमेंटेशन का डायग्राम में क्या देखते हैं? पीएएस को देखो, पीएएस में क्या है देखो, वहां पे सेगमेंटेशन का डायग्राम में पीएस में क्या है? पूरा सेगमेंट है, सेगमेंट 0, सेगमेंट 1, सेगमेंट 3, ऐसा है ना, राइट? सो इट मींस ओके, इन द नॉर्मल सेगमेंटेशन द एंटायर सेगमेंट विल बी ब्रॉट इनटू मेन मेमोरी. In the normal segmentation, the entire segment will be brought into main memory. Now remember, if the segment size increases, then it is unnecessary to bring the entire segment into main memory. If the segment size increases, it is unnecessary to bring the entire segment into main memory, because at any point of time the CPU will access only one word at any point of time. It means what? The CPU will access word by word, instruction by instruction, it will execute. Is that clear for everyone? Right? Okay, now understand here. Okay, in the normal segmentation क्या होता है? Okay, entire segment will be brought into main memory. This entire segment will be brought into main memory. Remember, it is unnecessary to bring this entire segment into main memory. Why? Because at any point of time, the CPU will access only one instruction, like instruction by instruction, word by word chalega. Is that clear? So, if the segment size increases, it is unnecessary to bring the entire segment into main memory. So, that is the reason to avoid the overhead of bringing, large size segment. To avoid the overhead of bringing large size segment into main memory. To avoid overhead of bringing large size segment into main memory, the concept of segmented paging is implemented. The concept of segmented paging is implemented. In the segmented paging, paging will be applied on the segment. Paging will be applied on the segment, and instead of bringing the entire segment into memory, instead of bringing the entire segment into main memory, the pages of segment will be brought into memory. Is that clear? So, अभी क्या करने वाले हैं बताओ? We are going to apply paging on the segment, and instead of bringing the entire segment into main memory, the pages of segment will be brought into main memory. Is that clear? See, okay, simple point है. Okay, if the segment size अगर बहुत ज़्यादा हो गया तो पूरा segment को memory में लाना, okay, waste of memory. Is that clear? Why? Because at any point of time CPU क्या करता है? Only one instruction को चलाता है. मतलब instruction by instruction ऐसा चलाते जाएगा. Is that clear? So it is unnecessary to bring the entire segment into main memory. So that is the reason. Okay, repeat कर रहा हूँ. To avoid overhead of bringing the large size segment into main memory, the concept of segmented paging is implemented. Now, in the segmented paging, अपन क्या करने वाले? अपन यहाँ पे क्या करने वाले? We are going to apply paging on the segment, and instead of bringing the entire segment into main memory, the pages of segment will be brought into memory. Is that clear? So, first of all, okay, understand here why we are doing all this. ये सब क्यों कर रहे हो? Same goal of memory management. Tell me, what is the goal of memory management? Goal of the memory management, batao. The efficient utilization of memory. Whatever the memory we are having, we have to make use of that memory in a efficient manner. Is that clear? So that is the reason we are doing all that. Is that clear? So how we are going to apply paging on the segment, and how we are going to bring the pages of segment into main memory? So that concept we are going to study now. Is that clear? Right. Now remember, so please listen the concept carefully. So ultimate goal is to solve the problems. Is that clear? And remember, I will explain only concept. All the questions you should only solve. Is that clear? I will explain only concept. All the questions you should only solve. Is that clear? Going forward also, same thing I follow. Is that clear? Right. So because, okay, if you follow my concept carefully, all the questions you can solve. Is that clear? Right. So please listen carefully. Right. So come back to this. So what is the segment size we are having? Okay, that is a 64 kilowatts. So now, okay, if we go with the normal segmentation, okay, पूरा segment को memory में लाना पड़ता है. Is that clear? So that is the reason I am going to apply paging on the segment. Now I am considering page size of segment. बताओ कितना zoom किया? Page size of segment डब्बा में page size of segment as how much here? 1 kilowatts. I am assuming page size of segment as how much? 1 kilowatts. So it means, okay, by taking the page size of 1 kilowatts, I am going to apply paging on the segment. It means we are going to divide the segment. Into pages of size. बताओ, we are going to divide the segment into pages of size 1 kilowatts. Okay, we are going to divide segment into pages of size 1 kilowatts. So we will divide that, okay, into pages of size 1 kilowatts. So look at here. So I am applying the paging on the segment. So please copy this. Okay, already copy किया ना, उसको divide करो. So each page is having how much size here? 1 kilowatts. So 1 kilowatts. Okay, please copy this. ऑलरेडी कॉपी किया ना, उसको जस्ट डिवाइड करो, बस उतना ही. ऑलरेडी कॉपी किया आप लोग. ओके, जस्ट डिवाइड लाइक दैट. सो आई एम अप्लाइंग पेजिंग ऑन द सेगमेंट. अप्लाइंग पेजिंग मीन्स व्हाट? डिवाइडिंग द सेगमेंट इनटू पेजेस. अप्लाइंग पेजिंग ऑन द सेगमेंट, इसका मतलब क्या है? अप्लाइंग पेजिंग ऑन द सेगमेंट, इसका मतलब क्या है? वी आर डिवाइडिंग द सेगमेंट इनटू पेजेस. नाउ आई अज्यूम द पेज साइज हाउ मच हियर? 1 kilowatts. Now tell me, if I divide the segment into equal size pages of size 1 kilowatts, then how many pages you get on the segment? This segment is having how much size? Values के साथ में समझो, values के साथ में समझो. This segment is having how much size? 64 kilowatts. If I divide that into page size 1 kilowatts, how many pages you get on segment? Number of pages. Okay, number of pages on segment. Copy करो, number of pages on segment. Okay, कैसा आएगा? Segment size divided by segment size divided by page size. Page size, how much is that? 64 kilowatts divided by 1 kilowatts. How much is that? 64. Okay, so how many pages you get? 64. So number of pages on segment. Okay, if you want you can keep that in a box. So this one you can keep in a box. Okay, so number of pages on segment equal to segment size divided by page size. So segment size कितना है बताओ अपना? 64 kilowatts है. Okay, segment size is 64 kilowatts. So if I divide that, okay, page size कितना है? 1 kilowatt. So how many pages you get? 64. So okay, you can copy here. So 64 pages you get like this: 0, 1, 2, 3, 4, like this. How many pages? 0 to 63. Okay, so 0 to 63, total 64 pages you get here. Okay, समझ में आया सबको? कॉपी करो इसको, ये भी 0 to 63, total 64 pages. Okay, now understand here. So total, okay, 64 pages you are getting here. So like this, 0 to 63, that's total 64 pages you are getting. Now remember, understand here. Okay, I told you already, okay, in the paging calls, okay, in the paging class, okay, I told you in the paging class, whenever the paging is applied, we need to maintain what? Page table. Whenever the paging is applied, we need to maintain the page table. Understand here. Whenever the paging is applied, the page table has to be maintained. So here, we are applying paging on the segment. Okay, listen here, we are applying paging on the segment. So when you apply paging on the segment, okay, how many pages you got here? 64 pages. Remember, to represent 64 pages of segment, you also need to maintain what? Page table. You also need to maintain page table. So wherever you apply paging, you need to maintain the page table. So here we applied paging on the segment. We got 64 pages. To represent 64 pages, we need to maintain page table, and that is okay, this page table here. This page table here. देखो यहाँ पे क्या लिखा है? Okay, this page table क्या लिखा है यहाँ पे बताओ? Page table of segment. Page table of segment. इसका मतलब क्या है? Page table to represent pages of segment. Page table to represent pages of segment. So please don't confuse. Okay, कुछ भी confusion नहीं है. Everything is very clear and very simple also. Okay, दिखने में इतना बड़ा दिखता है. Okay, मगर कुछ भी नहीं है. Is that clear? Very simple, right? So okay, page table of segment. इसका मतलब okay, it means a page table to represent pages of segment. Now tell me, how many pages are there on the segment? How many pages are there? 64 pages. So it means how many entries will be there here? 64 pages are there. How many entries will be there in the page table? 64. Very good. 64. Okay, entries will be there. Copy karo. Copy this. 0, 1, 2, 3, 4, 5, 0 to 63. Okay, so 0 to 63 total. Okay, 64. Okay, entries will be there here. Now tell me. Okay, tell me this point. Important point here. बताओ अच्छे से. Number of entries. Number of entries in the page table of segment. Number of entries in the page table of segment. Number of entries in the page table of segment is same as number of entries in the page table of segment is same as number of pages on the segment. Is that here? So number of pages on the segment here. Is that here? So note down this point. So this is one of the important point. Note down. Number of entries, in the page table of segment. number of entries in the page table of segment, number of entries in the page table of segment is same as number of entries in the page table of segment is same as the number of pages on segment. Number of pages on a segment. Is that clear? Right. Okay. So understand here. So that is the okay meaning of that. Okay. So keep that in a box. Okay. उसको डब्बा में लगाओ. Okay. उसको डब्बा में लगाओ. लगाया? Right. Okay. Understand here. So that is the okay. So that is about the number of page table and the number of entries in the page table, right? So that is a 0 to 63. लिखे copy किए इसको सब लोग, right? We are having 64 entries. So why we are having 64 entries? Because that is same as number of pages on the segment. So segment के ऊपर जितना pages होगा उतना entries यहाँ पे होगा, right? Now, so I am coming from the first. Listen here. So I am coming from the first. The answer सुनो. The answer सुनो जैसे CPU always generates a logical address. CPU always generates a logical address, and logical address divided into two parts, yes and D here. Logical address divided into two parts, okay, yes and D here. So yes will tell you segment number and D will tell you segment offset. So I assumed the total logical address as 34 bits. So yes will tell you segment number. Listen carefully. Let's say I want to refer segment number 4. Just an example. So I want to refer segment number 4. So you take that segment number, index onto the segment table here. What are the segment number we are having? You take that segment number, index onto the segment table, and inside the segment table entry, okay, you take that segment number, okay, and you take the segment number, index onto the segment table, and inside the segment table entry, you are having two parameters. One is X and next is L here. Now, what is X here? What is X? I have written there. X means what? Base address of page table of respective segment. Base address of page table of respective segment. So, don't confuse. Okay, I am using a word called respective. Why I am using word called respective? Because you are having total 2 power 18 segments. On every segment, you are having paging. And every segment is having its own page table. So, whichever the segment you are referring, that particular segment ka page table ka base address. Is that clear? So, let's say you are referring, okay, segment number 4 here. So, this what is X here? X is the base address of page table of segment number 4. Is that clear? So, every segment के ऊपर भी paging है, हर segment के ऊपर paging है, हर segment का अपना अपना page table है. So, जो segment को अपन refer करना चाह रहा है, वो segment का page table का base address. समझ में आया सबको? Is that clear for everyone? Right? So, understand here. So, segment number 4 का, okay, page table का base address. So, with the help of that base address, वो base address किसका है? Segment number 4 का page table का base address. So, with the help of that base address, you come on to this page table here. Right? And next, you take the length of the segment. Understand here. So, you take the length of the segment L. So, you do the same comparison. Okay, you take the D here. अब बताओ, D will tell you what? Offset of the segment. D will tell you offset, word number, and what is the relation? ये दोनों में relation क्या होना चाहिए बताओ? D less than L होना चाहिए. लिखा है यहाँ पे already. D less than L होना चाहिए. So, okay, it means what? Whatever the word number you are trying to refer, that should be within the length of the segment. So, if the D less than L, if it is not followed, it means you are referring outside the segment or beyond the segment, or you say illegal address. If it is no, then the trap will be generated to operating system, okay, saying that CPU referring illegal address. Next, in case if it is yes, if the D less than L, if this condition is yes, if the D less than L, if the condition is yes, okay, then what is going to happen? Now remember, this is the new thing coming here. So this is the new thing coming here. The answer is no. Okay, ये नया चीज यहाँ पे आ रहा है. So if the D less than L, if the condition is yes, then what is happening here? The 16 bits of D, देखो 16 bits of D D मतलब क्या है बताओ? Segment offset. So segment okay offset. Okay, 16 bits of D is divided into two parts. Okay, so remember when I say the 16 bits of D is getting divided into, when I say the 16 bits of D is getting divided into, it means you are applying paging on the segment. You are applying paging on the segment. Okay, so the 16 bits of D is divided into two parts. Okay, that is P1 and D1. The 16 bits of D divided into two parts. Okay, P1 and D1. So what is the meaning of this P1 and D1? Okay, P1 D1 का मतलब क्या होता है? Okay, note down. P1 equal to number of bits required. Number of bits required to represent pages of segment. Number of bits required to represent pages of segment. और कैसे लिखते हैं पता है ना? Okay, right. So number of bits required to represent pages of segment or page number of segment. Or page number of segment. Now tell me, सोच के बताओ. Now number of bits required to represent pages of segment. Now tell me, how many pages are there on the segment? How many pages are there on the segment? 64. So if you are having 64 pages, so to represent 64 pages, how many bits are required? To represent 64 pages, पेज नंबर के लिए कितना बिट चाहिए? 6 बिट्स चाहिए. तो इसलिए P1 के लिए कितना बिट्स है? P1 के लिए कितना बिट्स है? 6 बिट्स है. Is that clear? So it means P1 will tell you page number of a segment. Next is what? D1. Okay, note down. D1 equal to, note down, D1 equal to number of bits required to represent pages of segment. Sorry, number of bits required to represent page size. Sorry, number of bits required to represent page size of segment. Okay, ऐसा लिखो अच्छे से. Okay, number of bits required to represent page size of segment or page of segment or word number of page of segment. Word number of page of segment. And one more R बताओ क्या होगा? One more R, page offset of segment. Page offset of a segment. Okay, understand here. So that is the okay page offset of segment. Okay, so meaning of all that is what? Same only. बताओ क्या होगा? क्या लिखे पूरा? Okay, first D1 के लिए क्या लिखे? Number of bits required to represent page size of segment. Now tell me what is the page size of segment here? Page size of segment कितना assume किया? Page size of segment 1 kilowatts. Look at here. So this is a page size of segment कितना assume किया? 1 kilowatts. Now tell me, to represent 1 kilowatts of page size, how many bits are required? To represent 1 kilowatts of page size, how many bits required? 10 bits required. So इसलिए okay D1 के लिए कितना bits है? 10 bits है. तो इसका मतलब P1 D1 में फिर से बताओ एक बार. P1 will tell you page number of segment. Which particular page of segment the CPU is trying to refer? मतलब you are referring. Okay, look at here. So this page or this page or this page or this page like this. Okay, P1 will tell you page number and D1 will tell you what? Page offset. वो पेज के अंदर कौन सा वर्ड को रिफर करना चाह रहा है? वो पेज के अंदर okay कौन सा वर्ड को रिफर करना चाह रहा है? So that is given by what? D1. Is that clear? Right. So understand here. Next, you take that page number. Let's say I want to refer page number 4. Just an example. Okay, look at here. So I want to refer this particular page. Okay, so I am rounding. Okay, here I am circling this. Okay, so now look at it. I want to refer this particular page of the segment. So let's say I want to refer page number 4 of the segment. You take that page number, index onto the page table here. So you take that page number, index onto the page table here. Now tell me why you are indexing onto this page table. Why you are indexing onto this page table? Because this is the page table to represent pages of the segment. This is the page table to represent pages of that segment. So that is the reason. Obviously, you take that page number, index onto the page table here, and inside the page table entry, so now you are getting what? Frame number. Inside the page table entry, now you are getting the frame number. It means what? This particular page of segment. Okay, what is the page? Okay, page number 4. This particular page of segment is available in this particular frame of PAS. So once you get the frame number, you can make what? A physical address. The ultimate goal is to find out the frame number, because the frame number will tell you the physical existence of the page, where the page is actually available in the main memory. So once you get the frame number, you make the physical address, and remember, whatever the D1 you are having here, you copy the same D1, okay, from here to here. Okay, what are the D1 you are having? You copy the same D1 from here to here. So from here you take the frame number. Okay, once you get the frame number, you make the physical address. With the help of this frame number, you go to the respective frame in the PAS. With the help of this frame number, you go to the respective frame in the PAS, and with the help of this D1, you go to the respective word, okay, inside the frame here. You go to the respective word inside the frame, and inside that word, you will have the instruction. Is that clear? So inside that word, you will have the instruction. The CPU will fetch that instruction and continue the execution. Is that clear? So this is how, okay, the segmented paging will be implemented. Is that clear? Now important point here. Now in the main memory, look at here in the main memory PAS, what you are bringing in the main memory? Now tell me, in the main memory what you are bringing? You are bringing this entire segment or a page of segment? Page of segment. Look at here in the PA, what you are having? F and D1. देखो यहाँ पे क्या है? D1 है. ओके, चेक कर लो सब लोग, यहाँ पे D1 लिखा है या D लिखा है? देखो, अगर कोई यहाँ पे D लिखा है, अगर यहाँ पे F and D लिखा है कोई, तो दैट इज एब्सोल्युटली रॉन्ग. अगर कोई यहाँ पे D लिखा है, दैट्स एब्सोल्युटली रॉन्ग. D मतलब क्या होता है? पूरा सेगमेंट होता है. ओके, D1 मतलब पेज ऑफ सेगमेंट. सो मेन मेमोरी में अपन किसको ला रहा है? पूरा सेगमेंट को नहीं ला रहा है. ओके, किसको ला रहा है? पेज ऑफ सेगमेंट को ला रहा है. यू आर ब्रिंगिंग द पेज ऑफ सेगमेंट इनटू, ओके, PAS or in the main memory. So it means what? Now tell me. Okay, important point next. Now tell me, okay, what you are bringing into main memory? Okay, you are bringing the entire segment or page of segment? Page of segment. It means page size of segment. Bolo, page size of segment is same as frame size of PAS. Okay, look at it. There are frames here. Frame size of PAS, because pages of segment are brought into frames. Pages of segment are brought into frames. So it means page size of segment is same as frame size of PAS. Note down the statement. Page size of segment. Page size of segment is same as frame size of PAS. Page size of segment is same as the frame size of PAS. Is that clear for everyone? Right. So understand why? Because the pages of segment are brought into frames. Is that clear? Right. So that is how, okay, the segmented paging will be implemented. Is that clear? So don't worry. So everything will be clarified. Okay, everything will be clarified by solving the questions. Is that clear? Right. So don't worry. Okay, टेंशन लेने की जरूरत नहीं है. So फर्स्ट टाइम जब पढ़ रहे हैं, थोड़ा इतना बड़ा डायग्राम देखे थोड़ा डर लगता है, राइट है. सो डरने की कोई जरूरत नहीं है. ओके, सो क्या है? ओके, डर के आगे जीत है, डरना नहीं है. इज दैट क्लियर? राइट. ओके, सो लेट्स ट्राई टू अंडरस्टैंड. ओके, नोट डाउन द क्वेश्चन. Please note down the question. Consider a system using segmented paging architecture. Consider a system using segmented paging architecture. Full stop. The segment is divided into यहाँ पर लिख रहा हूं देखो 1K pages. The segment is divided into 1K pages and each page is having 512 entries. यहाँ पे लिखता हूं जो भी वैल्यूज है बोर्ड के ऊपर लिख रहा हूं देखो. Segment is divided into 1K pages and each page is having 512 entries. Full stop. The segment number requires 17 bits. 17. The segment number requires 17 bits to represent. Segment number requires 17 bits to represent segments of LAS. Segment number requires 17 bits to represent all the segments of LAS. Full stop. The frame number requires 13 bits. 13 यहाँ पे लिखा है. Frame number requires 13 bits to represent frames of PAS. Frame number requires 13 bits to represent frames of PAS. Full stop. Memory is word addressable. And page table entry size is 2 words. यहाँ पे लिखा है page table entry size is 2 words, 2W. Page table entry size is 2 words. Full stop. Then calculate question number 1. Question number 1, length of logical address. Question number 2, length of physical address. Question number 3, page table size of segment. Page table size of segment. That's all. Okay. So 3 questions only. Right. So please try to solve them carefully. So I will wait 5 to 10 seconds, 5 seconds or 10 seconds in the live. Okay. So please pause the video. Okay. 1 minute suno idhar. Okay. You concentrate. Okay. You compare every statement of the question. So please compare every statement of the question with the diagram on the board. So try to compare every statement of the question with the diagram on the board. Is that clear? So step by step solve करो. Don't take tension. Okay, एक step by step, एक line को अच्छे से diagram में मैं कैसे किया? You compare with the diagram. Okay, question is very easy. So sincerely try to solve the problem. So whether it is a wrong or right doesn't matter. Sincerely try to solve the problem because you can clearly check. Okay, आप लोग कैसे सोच रहे थे, मैं कैसे सोचा था. You can easily compare and improve your analysis and thinking. So please sincerely try to solve the problem. Thank you. So I'll wait 5 to 10 seconds in the live. Okay, right. So let's see the solution to the problem. Okay, so the first question is asking what? First question is asking okay, logical address. Okay, length of logical address. So I'm just writing here. Okay, so I'm using this space here. Okay, listen here. So first question is asking logical address. Question number 1. So I don't have sufficient space. I'm writing here. So if you take the logical address divided to S and D here. Okay, logical address divided to S and D here, and your D is further divided into what? Okay, P1 and okay D1. Okay, so this is the logical address. You can check the diagram में check करो अच्छे से, diagram check करो यहाँ पे diagram में. Okay, logical address divided to S and D है, logical address divided to S and D, and your D is further divided to what? P1 and D1. So D is further divided to P1 and D1. So same thing, logical address divided to S and D, so D is further divided to P1 and D1. Okay, now read the question. Consider a system using segmented paging architecture. The segment is divided into 1K pages. Segment is divided into 1K pages बोल रहा है, बस इतना ही समझो. Segment is divided into 1K pages बोल रहा है. Okay, understand here. So when you say segment is divided into 1K pages, you compare that okay with the same statement, the diagram on the board. अपना segment divided into how many pages? Look at here, बिल्कुल आपके सामने अपना segment. Okay, अपना segment. Our segment is divided into how many pages here? Okay, 64 pages. Remember, our segment is divided to clearly visible, right? Our segment is divided to okay 64 pages, and the question is saying segment is divided to 1K pages. So when you say segment is divided to 1K pages, so now tell me, is talking about S or D? Segment is divided to 1K pages. Is talking about S or D? Is talking about the D, because the D will tell you segment offset, segment size. Yes or no? D will tell you that. S will tell you only segment number. Okay, कुछ लोग yes बोला है, इसलिए बोल रहा हूँ, right? So okay. Now segment is divided into 1K pages. So it's talking about D. So now D is further divided into two parts, P1 and D1. When you say segment is divided into 1K pages, segment के ऊपर 1K pages है. So P1 requires how many bits? Okay, P1 के लिए क्या लिखे थे? Notes में पढ़ो एक बार. What you have written for the P1? What you have written for the P1? Okay, P1 is LU. Okay, number of bits required to represent pages of segment or page number of segment. So it means that will tell you, P1 will tell you page number, and segment is having how many pages? Segment is given to how many pages in the question? 1K pages. If you are having 1K pages, how many bits required for the P1? Okay, so 10 bits required for the P1 here. Okay, and next continue the question. Segment is divided to 1K pages, and each page is having how many entries? 512 entries. 512 entries. So it means D1 requires how many bits? 9 bits. Okay, D1 requires 9 bits. Okay, now remember, so P1 D1 to aa gaya. So if you want to find out the total logical address, so what is required? What else is required here? S is required. So S will tell you what? Segment number. So that is given in the question only directly. Segment number requires how many bits? 17 bits. Okay, segment number requires 17 bits. Okay, so now you can solve this. Okay, add karo. So 17 plus 19. Okay, 17 plus 19. How much is that? Okay, 36. 36 bits. Is that clear for everyone? Okay, sahi hai na? 36 bits. Okay, fine. So understand here. So that is the 36 bits logical address. Question number 1. So question number 2. Question number 2 is asking what? Physical address. Physical address diagram में देखो. Physical address में क्या है? F and D1 है. फिजिकल एड्रेस में क्या है? F1 D1 है. देखो यहाँ पे फिजिकल एड्रेस में क्या है? F1 D1 is there. So D1 के लिए how many bits are required? How many bits required for D1? Already we found D1 requires how many bits? 9 bits. So 9 bits are required for the D1, and F will tell you what? Frame number. So frame number requires how many bits? F will tell you frame number. Okay, frame number के लिए कितना bits दिया? Question में दिया कितना bits? 13 bits. So 13 bits are given for the frame number. So 13 plus 9. So how much is this value? 22. Correct? सही है ना? So total 22. So PA is how much here? 22 bits. So this is the question number 2. Okay. Okay. So PA is the 22 bits. So this is the question number 2. Okay. So next, now coming to the question number 3 is asking what? क्वेश्चन नंबर 3 क्या पूछा है बताओ? पेज टेबल साइज ऑफ सेगमेंट, पेज टेबल साइज ऑफ सेगमेंट, पेज टेबल साइज ऑफ सेगमेंट। बताओ पेज टेबल साइज ऑफ सेगमेंट कहां पे? पेज टेबल ऑफ सेगमेंट डायग्राम में कहां पे? पेज टेबल ऑफ सेगमेंट इज आस्किंग पेज टेबल साइज ऑफ सेगमेंट, पेज टेबल ऑफ सेगमेंट डायग्राम में कहां है? यहां पे। ओके, पेज टेबल ऑफ सेगमेंट यहां पे, यस और नो? पेज टेबल ऑफ सेगमेंट यहां पे। ओके, सो इसका साइज अगर आपको निकालना है, ओके, पेज टेबल का साइज निकालना है, ये पेज टेबल का साइज निकालना है, तो हाउ यू गेट द पेज टेबल साइज? सेम फार्मूला, नंबर ऑफ एंट्रीज इन द पेज टेबल, number of entries in the page table is same as multiply with the page table entry size. Number of entries in the page table multiply with the page table entry size. So I write here. Okay, so I'm just removing this. Okay, now tell me. Okay, page table size of segment, page table size of segment equal to number of entries in a page table of segment, number of entries in the page table of segment multiply with the page table entry size, page table entry size. Okay, the answer is what you say. Number of entries in the page table of segment is same as number of pages on segment, number of pages on segment, number of entries in the page table of segment same as number of pages on segment. Now tell me how many pages are there on the segment? Okay, question में क्या दिया? Okay, ये समझ में है ना? Number of entries in the page table of segment is same as number of pages. डब्बा में लिखा है, डब्बा में लिखा नोट्स में, right? Number of pages on segment. Now tell me number of pages on segment कितना दिया? Segment is given to how many pages? 1k pages. So that is okay 1k and multiply with the page table entry size. The page table entry size कितना दिया? 2 words. So that is how much? 2 kilowords, 2 kilowords. So this is how, okay, you solve the problem. Is that clear for everyone? So you can make a proper notes. So please copy carefully. Right. Note down the next question. Note down. Consider a system. Consider a system using segmented paging architecture. Consider a system using segmented paging architecture, full stop. Segmented paging architecture, full stop. The segment is divided into the segment is divided into 8k pages. Segment is divided into 8k pages. So I am writing here segment is divided into 8k pages and each page is having 2k entries. Segment is divided into 8k pages. 8k pages and each page is having what? 2k entries, full stop. Segment number requires 19 bits. Segment number requires 19 bits to represent. Segment number requires 19 bits to represent all the segments of LAS. Segment number requires 19 bits to represent all the segments of LAS. Okay, full stop. Memory is byte addressable. Memory is byte addressable. Full stop. The PAS, physical address space. Physical address space. PAS is 512 KB. PAS, physical address space. Okay, PAS is 512 KB. 512 KB and page table entry size. Page table entry size यहाँ पे लिख रहा हूँ. Page table entry size is 8 bits. Page table entry size is 8 bits. Okay, page table entry size is 8 bits. Full stop. Then calculate. Then calculate question number 1. Question number 1. length of logical address. Question number 1, length of logical address. Question number 2, length of physical address. Question number 2, length of physical address. And question number 3, page table size of segment. Page table size of segment. And question number 4, number of frames in the PAS. Okay, you are having question number 4 also. Question number 4, number of frames in the PAS. Number of frames in the PAS. Is that clear? So, try to solve all the questions carefully one by one. Okay. So, I will wait 5 to 10 seconds in the live. Okay. So, then I will discuss the solution. Think carefully and solve. So, what is the answer you are getting? So, all of you done? Right. So, let us see what is the right answer. So, first question is asking logical address. Now, same thing, logical address. Look at here what it says. Consider system using segmented paging architecture. Segment is divided into 8K pages bola. Segment is divided to 8K pages. If the segment is divided to 8K pages, okay, segment is divided to 8K pages. So, P1 requires how many bits? 13 bits. So, okay, look at here. So, I use a different pen. Okay. So, segment is divided to 8K pages. So, it means P1 requires how many bits? 13 bits. And each page is having how many entries here? 2K entries. So, D1 requires how many bits? 11 bits. Okay, so that is clear. And next, segment number requires how many bits? Segment number requires 19 bits. So, that is given to you. So, yes, requires 19 bits. So, please add all of them. So, this is 30 plus, okay, 13. So, that is what? 43 bits. Okay, all of you got same? 43 bits. Okay, right. So, that is the question number 1. And next, question number 2 is asking physical address, length of physical address. Remember, it is given to you PAS. PAS is given 512 KB. So, PAS is a 512 KB. Then PA will be what? Okay, straight away you can write 19 bits. Okay, even if you want to write like this also, you can write F under D1. Okay, look at here. F under D1. So, D1 requires how many bits? 11 bits. Okay. D1 के लिए कितना बिट्स चाहिए बताओ 11 बिट्स है and total PA is what? Okay, PAS is a 512 KB, so PA is a 19 bits है. So okay, D1 के लिए 11 बिट्स है तो F के लिए कितना बिट्स होगा 8 बिट्स होगा, right? So even if you write like this कैसे भी लिखो, so PAS दिए तो डायरेक्टली PA लिख सकते हैं ना, उसमें क्या है? So PAS 512 KB है, so सीधा PA is a 19 bits है, so directly you can write. So next question number 3 is asking page table size of segment. Same thing, number of entries in the page table of segment multiply with the page table entry size. Number of entries in the page table of segment same as number of pages on the segment. Now how many pages are there on the segment? Segment is divided to how many pages? Segment is divided to how many pages? 8K pages. 8K pages. So that is 8K multiply the entry size. Page table entry size कितना दिया? 8 bits. 8 bits यानी 1 byte. So this is how much here? 8 KB. So that is 8 KB. So that is how you solve the question number 3. And next question number 4 is asking number of frames in the PAS. Okay, look at here. So this is question number 3. Okay, question number 4. So number of frames in the PAS. Okay, number of frames. Number of frames. Now tell me F के लिए कितना bits है? How many bits are there for the F here? F is having how many bits? 8 bits. So if F is having 8 bits, then the number of frames will be how much? So that is 2 power 8. That is 256. Is that clear? So कुछ लोग ऐसा ही 8 लिखा है, कुछ लोग somebody written 8 only. So very bad. So F requires 88 bits means number of frames will be how much? 2 power 8. That is 256. Is that clear? So this is how, okay, you need to solve the problem. So that is question number 4. So is it clear for everyone? Okay, all the questions are clear. And the next question is okay, good question and okay, important question. So let's try to solve that. Go to your workbook. Go to your workbook. Page number 106. Page number 106, question number 28. Page number 106. So I am writing here page number 106, question number 28. Question number 28. So think carefully and try to solve the problem. Think carefully and try to solve the problem. सो आई विल वेट अराउंड 10 सेकंड्स। आप पास करो अच्छे से, अच्छा क्वेश्चन है, ओके, गलत भी हो सही हो सॉल्व करो, ओके, डोंट कंटिन्यू द वीडियो, कंटिन्यू नहीं करने का, बिल्कुल नहीं करने का, इसलिए सो 10 सेकंड मैं वेट करके सॉल्यूशन बताऊंगा। सो आप लोग पास करो, वीडियो पास करो अच्छे से, वीडियो पास करके सॉल्व करो। Right. So next, okay, let's solve the question. What it says in the question? Listen carefully. Right. Consider a system. Okay, somebody is not understanding the question. कुछ लोगों को क्वेश्चन ही समझ में नहीं आ रहा है कि क्या पूछ रहा है ये. ओके, राइट. सो डोंट वरी. ओके, आई विल एक्सप्लेन दैट. अगर आप सॉल्व कर रहे हैं, पास करो, पास करके फिर से ट्राई करो अच्छे से एक बार. सॉल्यूशन नहीं देखना, कंटिन्यू नहीं करना वीडियो. अगर आपका ओके ट्राई करना खत्म हो गया, बस मैक्सिमम ट्राई कर लिया, खत्म हो गया ट्राई करना, देन ओनली यू कंटिन्यू द वीडियो. प्लीज बी सिंसियर. राइट. So consider a computer, okay, where logical address and physical address space is the 2 power 16 bytes. So it means what? Okay, LAS, okay, equal to PAS equal to 2 power 16 bytes. So this is given to you. LAS equal to PAS equal to 2 power 16 bytes. Okay, next. The segment is okay. Now look at the segmented paging architecture applicable. Full stop. Virtual address is divided into, okay, understand here, virtual address space, LAS. LAS is divided into 8 equal size segments. Okay, that's the next point he has given. Okay, LAS, virtual address space matlab LAS. Okay, logical address space. So logical address space LAS is divided into, understand here, LAS is divided into 8 equal size segments. 8 equal size segments. Now understand here. So logical address. Now tell me, logical address will be how much? Logical address 16 bits. Okay, LAS अगर 2 power 16 bytes है, byte addressable memory है, तो LA कितना होगा? 16 bits होगा. Yes or no? LA 16 bits होगा. And LA will be divided into 2 parts, S and D. Segmentation में ऐसे ही divide होता है, S and D. Next क्या दिया क्वेश्चन में? LAS, logical address space, LAS is divided into what? 8 equal size segments. LAS के ऊपर कितना सेगमेंट्स है, कितना नंबर ऑफ सेगमेंट्स कितना है? 8 है. सो 8 सेगमेंट्स है, तो सेगमेंट नंबर के लिए कितना बिट्स होगा? 3 बिट्स होगा. सेगमेंट नंबर रिक्वायर्स 3 बिट्स एंड सेगमेंट नंबर के लिए 3 बिट गया, तो डी के लिए कितना होगा? 13 बिट्स होगा. ओके, सो अंडरस्टैंड हियर. सो सेगमेंट LAS इज डिवाइडेड इनटू 8 सेगमेंट्स. सो LAS कितना है? 2 पावर 16 बाइट्स है. इसको डिवाइडेड बाय 8 करो, इसको डिवाइड बाय 8 करे तो कितना क्या मिलेगा? एक एक सेगमेंट का साइज मिलेगा. ओके, सेम वही तो बात हुआ, राइट. So LAS is the virtual address space is divided into what? Virtual address space divided into what? Virtual address space divided into 8 equal size segments. Okay, so इसको 8 से डिवाइड करें तो okay, हर एक सेगमेंट का साइज आएगा. Now tell me segment size कितना होगा? सेम मतलब सेम है, ऐसे ही है, सेम. सेगमेंट साइज सेगमेंट साइज कितना होगा बताओ? 2 पावर 13 बाइट्स होगा. डी वैल्यू अगर 13 बिट्स है तो मैक्सिमम सेगमेंट साइज कितना होगा? 2 पावर 13 बाइट्स होगा. सो सेगमेंट साइज इज 2 पावर 13 बाइट्स. यहां तक समझ में आया सबको? राइट. नेक्स्ट आगे पढ़ो. आगे क्या दिया? सेगमेंट इज डिवाइडेड इनटू इक्वल साइज पेजेस. Segment is divided into equal size pages which are of powers of 2. Okay, now look at here. So segment is divided into equal size pages. So he is applying paging on the segment. Listen carefully. Segment is divided into equal size pages which are of powers of 2. वो pages कैसा है बताओ? Powers of 2 में है. Is that clear? So it means you need to understand. क्या समझना है? Page size of segment. बताओ, पेज साइज ऑफ सेगमेंट क्या अज्यूम करोगे? पेज साइज ऑफ सेगमेंट क्या अज्यूम करना चाहिए बताओ? हाँ, पेज साइज ऑफ सेगमेंट कितना अज्यूम करना चाहिए? 2 पावर x बाइट्स अज्यूम करना चाहिए. 2 पावर x बाइट्स. ओके, क्या दिया क्वेश्चन में? फिर से बता रहा हूं. सेगमेंट इज डिवाइडेड इनटू equal size pages, equal size pages which are of powers of 2. So वो पेज साइज कैसा है, powers of 2 में है, इसलिए powers of 2 में है तो कितना पावर है पता नहीं है, powers of 2 में है तो कितना पावर है पता नहीं है. So simply assuming page size segment as what, 2 power x bytes. Is that clear for everyone? Right. Okay. Next क्या दिया बताओ, memory is a byte addressable and page table entry size is what, 2 bytes. Okay, page table entry size, page table entry size, okay, is a 2 bytes. Okay, page table entry size 2 bytes. Next, now page tables are stored in the main memory. That is also given to you. Already you know that page tables are stored in the main memory. ये कोई बताने की जरूरत नहीं है. So you already know that. Okay, next. Now what is the question is asking? Let's try to understand that point. Okay, that point. What must be the size of page of segment? What must be the size of page of segment in bytes so that page table of segment exactly fits in one page frame? Page table of segment exactly fits in one page frame. Understand here. Okay, इतना बड़ा line दिया. What must be the, okay, size of page of segment? इसका मतलब क्या है? What must be the size of page of segment? इसका मतलब page size of segment क्या होना चाहिए? इतना ही है, कंफ्यूज करने के लिए इतना बड़ा स्टेटमेंट दिया. What must size of page of segment? मतलब page size of segment. Okay, what should be the page size of segment so that page table of segment exactly fits in a one page frame. Page table of segment exactly fits in a one page frame. Okay, so understand here what do you want to do. करना क्या चाह रही है, करना क्या चाह रहा है. ओके, पेज टेबल ऑफ सेगमेंट को एग्जैक्टली फ्रेम के अंदर फिट करना चाह रहा है. पेज टेबल ऑफ सेगमेंट को एग्जैक्टली फ्रेम के अंदर फिट करना चाह रहा है. पहले ये बताओ पेज टेबल ऑफ सेगमेंट कहां पे है, डायग्राम में बताओ. डायग्राम में पेज टेबल ऑफ सेगमेंट कहां पे है, डायग्राम में पेज टेबल ऑफ सेगमेंट कहां पे है, देखो यहां पे पेज टेबल ऑफ सेगमेंट बिल्कुल आपके सामने. सो पेज टेबल ऑफ सेगमेंट को, ये पेज टेबल ऑफ सेगमेंट को एग्जैक्टली फ्रेम के अंदर फिट करना चाह रहा है. So this is a page table of segment. ये page table of segment, this page table of segment, okay, is trying to fit exactly in the frame here, exactly in one frame here, exactly one frame. The page table of segment is trying to fit exactly in the one frame. Okay, ये page table of segment को exactly frame के अंदर fit करना चाह रहा है. ऐसा क्यों fit करना चाह रहा है, ऐसा क्यों fit करना चाह रहा है? Why is trying to fit like that? Because the page table will be stored in the main memory only. Main memory means what? PAS. PAS means what? Frame only. So this page table will be available inside the frame only, right? Inside the frame only. So करना क्या चाह रहा है, ये पूरा page table को, you want to fit this entire page table exactly into one frame here. Now remember, if you want to, okay, fit this entire page table into exactly in one frame, if he is trying to print, okay, fit this entire page table into exactly in one frame, then you should ask for what? This frame size. अगर ये पूरा पेज टेबल को एग्जैक्टली फ्रेम के अंदर फिट करना चाह रहा है तो ये क्या पूछना चाहिए, फ्रेम साइज पूछना चाहिए ना. मगर ये क्या पूछ रहा है, क्या पूछ रहा है, व्हाट शुड बी द पेज साइज ऑफ सेगमेंट. इज आस्किंग व्हाट मस्ट बी द साइज ऑफ पेज ऑफ सेगमेंट, मतलब पेज साइज ऑफ सेगमेंट इज आस्किंग. इज आस्किंग व्हाट, पेज साइज ऑफ सेगमेंट इज आस्किंग, पेज साइज ऑफ सेगमेंट. इज दैट क्लियर फॉर एवरीवन? राइट. आप बताओ यहाँ पे अगर ये पूरा पेज टेबल को एग्जैक्टली फ्रेम के अंदर फिट करना चाह रहा है तो ये फ्रेम साइज पूछना चाहिए, बिकॉज देयर आर फ्रेम्स, राइट. फ्रेम साइज पूछना चाहिए, मगर ये क्या पूछ रहा है, पेज साइज ऑफ सेगमेंट पूछ रहा है. इज आस्किंग पेज साइज ऑफ सेगमेंट. व्हाई? बिकॉज बोथ आर सेम, बोथ आर सेम. नोट्स में लिखा है, नोट्स में इट इज क्लियरली देयर, पेज साइज ऑफ सेगमेंट, पेज साइज ऑफ सेगमेंट नोट्स में है. ओके, डब्बा में होगा, डब्बा में है, पता नहीं डब्बा लिखे ना लिखे. सो पेज साइज ऑफ सेगमेंट इज सेम एज frame size of PAS, frame size of PAS. This is there in the notes. मतलब whether he is asking page size of segment or whether he is asking frame size, okay, does not matter because both are same. Both are same. Why? Because pages of segment are brought into frames. Is that clear? Right? अब बताओ करना क्या चाहिए. नेक्स्ट, अभी क्वेश्चन तो समझ में है, क्वेश्चन तो समझ में है. अभी ये रिपीट कर रहा हूं, क्वेश्चन का मतलब क्या है. ओके, इज ट्राइंग टू फिट दिस एंटायर पेज टेबल ऑफ सेगमेंट एग्जैक्टली इन वन फ्रेम. ओके, इज ट्राइंग टू फिट, ओके, दिस एंटायर पेज टेबल ऑफ सेगमेंट into exactly one frame सो टू डू सो, ऐसा करने के लिए, ओके, इन ऑर्डर टू डू दैट व्हाट शुड बी द, ओके, पेज फ्रेम साइज, size of the frame, page frame, or say what should be the page size of segment, or what should be the, okay, frame size of PS. Both are same only, whether is asking page size of segment or frame size of PS, दोनों का मतलब सेम ही है. बताओ कैसे करोगे, how you proceed to solve the problem. Those who are not solved, you have to tell me this. Those who are not solved, okay, you need to think, idea तुमको आना चाहिए, आइडिया तुमको आना चाहिए, ओके, मैं करने से पहले, मैं बोलने से पहले तुमको आना चाहिए. ओके, सो नाउ टेल मी, सो ओके, अब बताओ पेज टेबल ऑफ सेगमेंट को एग्जैक्टली फ्रेम के अंदर फिट करना है, तो करना क्या चाहिए बताओ. पहले तो फर्स्ट स्टेप, नेक्स्ट स्टेप क्या करना है, ये पेज टेबल का साइज तो निकालो, पेज टेबल का साइज तो निकालो, यस और नो, राइट. सो फाइंड आउट पेज टेबल साइज ऑफ सेगमेंट, page table size of segment. Now tell me how you get page table size of segment. Same formula, number of entries in a page table of segment, number of entries in the page table of segment multiply with the page table entry size. बताओ number of entries in the page table of segment, this is same as number of pages on segment, number of pages on segment, number of pages on segment, this same as segment size divided by, okay, page size, segment size divided by page size, yes or no, right. So number of entries in the page table of segment same as number of pages on segment, number of pages on segment कैसा आएगा, segment size divided by page size, okay. Now okay, I am writing here, so I am writing, so continuation, okay. Okay, so now tell me, so what is this here, okay, okay, sorry, यहाँ पे लिख रहा हूँ, okay, continuation, just listen here. Now tell me what is that value, segment size divided by page size. What is the segment size, आपके सामने segment size कितना है, 2 power 13 bytes, page size कितना है, page size of segment कितना है, 2 power x bytes, so 2 power 13 bytes divided by 2 power x bytes. So multiply with the entry size, page table entry size तो होगा, page table entry size कितना दिया, 2 bytes दिया, क्वेश्चन में दिया, that is 2 bytes. So BB cancel, this value is how much, 2 power 14 minus x bytes, okay. So this is 2 power 13, 2 power 1, that is 2 power 14, x अगर ऊपर गया तो minus x होगा, right. So this is the page table size of a segment. ये क्या है बताओ, page table size of segment. Now अभी next करना क्या चाह रहा है वो, पेज टेबल साइज ऑफ सेगमेंट को, पेज टेबल साइज ऑफ सेगमेंट को एग्जैक्टली फ्रेम के अंदर फिट करना चाह रहा है, पेज टेबल ऑफ सेगमेंट को एग्जैक्टली फ्रेम के अंदर फिट करना चाह रहा है. सो ऐसा फिट करना चाह रहा है तो इसका मतलब क्या करना, व्हाट यू हैव टू डू, यू हैव टू इक्वेट बोथ ऑफ देम, राइट. सो पेज टेबल साइज ऑफ सेगमेंट, पेज टेबल साइज ऑफ सेगमेंट मस्ट बी इक्वेटेड विद व्हाट, ओके, मस्ट बी इक्वेटेड विद द फ्रेम साइज, फ्रेम साइज, ओके. सो एग्जैक्टली वो फ्रेम के अंदर फिट करना चाह रहा है, सो फ्रेम साइज से इक्वल करना है. सो पेज टेबल साइज ऑफ सेगमेंट कितना है बताओ, 2 power 14 minus x bytes. So frame size how much here, frame size, page size both are same. What is the page size we assumed, page size of segment कितना assume किया, 2 power x bytes. So this must be equated with what, 2 power x bytes. So b भी cancel, अगर ये इधर गया तो क्या होगा, 2 power 14 equal to 2 power 2x, करेक्ट. सो इधर गया तो 2 power 2x होगा. सो इसका मतलब 2x इक्वल टू 14 एंड x इक्वल टू 7, x इक्वल टू 7. सो अपन क्या अज्यूम किया, पेज साइज ऑफ सेगमेंट, पेज साइज ऑफ सेगमेंट कितना अज्यूम किया, 2 power x bytes, 2 power x bytes, ओके. पेज साइज ऑफ सेगमेंट इज 2 power x bytes, 2 power x वैल्यू कितना है यहाँ, 7 bytes. So 2 power 7 bytes is how much, 128 bytes, okay. So 128 bytes, okay. So right answer is okay, this is 128 bytes. So this is how you solve the problem. So right answer is what, B is the right answer. If anybody want to copy, मैं साइड हो रहा हूँ, साइड हो जा रहा हूँ, अच्छे से कॉपी करो. right? You can pause this and continue to copy, right? If anybody want to copy. So this is how, okay, you need to solve the problem, okay? Check कर लो आप लोग कैसे सोचे थे और मैं कैसे बनाया, okay? So please try to think of all this. Is that clear? So this is how, okay, you need to solve the problem, and this is how the questions can be asked. Is that clear? Right. So that is okay, segmented paging. Is that clear? So with this, okay, we have completed memory management techniques. Memory management techniques. So if you observe the memory management techniques, okay, now tell me, memory management techniques are categorized two types, contiguous and non-contiguous. Okay, so in the contiguous, okay, contiguous, what are the different types? In the contiguous, fixed partition scheme and variable partition scheme. And next, in the non-contiguous, okay, paging, multi-level paging, inverted paging, segmentation and segmented paging. Is that clear? Right. So, okay, now you need to solve all the problems of workbook, okay, from the chapter 6. Chapter 6 he has given, okay, memory management. You need to solve all the problems of chapter 6. Okay. Now remember, so please read the notes carefully, follow the notes carefully, understand that, and if you solve the workbook, this workbook, I think around 40-45 questions are there. Okay, it will take maximum 1.5 hour, maximum 2 hours. So it will not take more than 2 hours to solve this entire workbook. Is that clear? So what is pending? Okay, next in the memory management is what? Virtual memory. Is that clear? So that is also one of the important topic. Okay, virtual memory. So okay, next maybe in the continuation next session I may discuss the workbook, because workbook is also pending. Okay, for us that is, I think deadlocks is also pending, synchronization is also pending, right? So we will discuss the workbook, and next maybe, or I may discuss the virtual memory. Is that clear? So thank you. So I am assuming all of you following the class. So thank you so much.